Hey everybody, this is video 2 for this week. Again, with this idea of different strategies for solving quadratic equations. In this video, we're going to talk about factoring, and that should be our favorite because we've been factoring for a number of years now. So let's take a look at how we can factor to solve quadratic equations. So again, quick reminder, a quadratic equation um, has an answer, right? It's some series of x's, so something that follows that form of ax squared plus bx plus c, and it'll have some answer to there'll be some number equals whatever that number d is. And one thing that we're going to find is more often than not, the easiest thing to do is to make sure that this number here is a 0, because then we're just looking for x-intercepts, which is something that we've done a lot. So a method which is often quicker than most is to solve by using factoring. When you become proficient at factoring, it becomes the easiest and the quickest method to solve these things. So it is one that I would highly, highly recommend practicing and getting good at. So a couple of steps when it comes to trying to solve these things by factoring. Step one, make it equal to 0. And that's what I just said, right? As soon as you have a quadratic equation that's now equal to 0, we've taken it from some random equation to here's my quadratic, let's find my x-intercepts, which is something that we've practiced doing for a while now. Okay, once you have it set equal to 0, so for example, x squared plus 5x plus 6, it's now equal to 0. All right, let's factor this thing. And we have a lot of different ways of factoring, right? Factoring by inspection, factoring by slide and divide, factoring by difference of squares. So whatever the strategy is, that's what we have to use. So in this case, we'd factor by inspection, right? We'd find two numbers that add to give me 5, multiply to give me 6, and what we find is those two numbers are x plus 3 and x plus 2. Once you have these two brackets, your next step is to take each of those brackets separately and set them equal to 0. So set each bracket to 0. This works because the product of any number times 0 is how we're going to get this answer 0. So if this bracket were 0, this bracket could be any other number because 0 times any number gives us 0. And then the opposite is also true. So for this one, we're going to say, okay, well, when does x plus 3 equal 0? And when does x plus 2 equal 0? And then it's just a matter of bringing the number to the other side. So x is equal to, we're going to subtract 3 from this side and subtract 3 from this side, and we get x is equal to negative 3, right? And same thing here, subtract 2, subtract 2, so x is equal to negative 2. So what we see is that there's two possible answers. There's an answer here when x is negative 3, and there's an answer here when x is negative 2. A lot of students get so comfortable with this idea that they're just like, all right, negative 3, negative 2, they can get it right from the bracket, which is great. The only thing you have to be careful of is what happens when there's a number in front of the x, right? So that's why it's useful to not skip this step and to actually write it out, setting your bracket equal to 0 and solving. Then once you have your answers for x, right, then yeah, those are our answers. So we get x equals negative 3, x equals negative 2, right? Something we should be familiar with, whether you remember it or not, we have seen it. So just as a quick, before we get into it, let's practice factoring. So again, good time to pause the video and try these three questions for me. Then once you think you have answers, start it back up and check your work. So for part A, what I would do is I would factor this by using a greatest common factor to start, right? So A is 2x squared minus 2x minus 12. And what we know is that 2, 2, and 12 can all be divided by 2. So that is a common factor. So we get 2 onto x squared minus x minus 6. Now that there's no longer a number in front of my x squared, this can be factored by inspection, right? So 2 is still there. I'm looking for two numbers that multiply to give me negative 6, but add to give me negative 1. And the answer is minus 3 and x plus 2. Right? So we're just going to stop there, right? This is asking us to just factor an expression. There is no answer. It's not equal to 0. It's just saying here's an expression, try to factor it. So we're just going to stop here for now. All right, part B, same idea. So 1/4 x squared minus x minus 3. And you might look at this and say, okay, well, how do I deal with something like this? And actually, we can deal with this thing exactly the same way that we just dealt with the previous one. What we can do is whatever number's in front of your x squared, right? It can be factored out, right? You can take it out of the bracket, even if it's a common factor or not. So if I have 1/4 and I divide it by 1/4, anything divided by itself just leaves me with 1. Okay. And then when I have this one, this is a -1 being divided by 1/4. To divide by 1 over 4 is the same thing as multiplying by the reciprocal, right? Flip the guy and multiply, keep, change, flip. Whatever it is you've been taught, that's what we need to do. So -1 divided by 1/4 is the same thing as -1 times 4. And the same thing is true for the 3, -3 times 4. And we end up with this. Okay, so again, the 1/4 stays there, and then we can factor. So now I'm looking for two numbers that add to give me -4, but multiply to give me -12, and it is x minus 6 and x plus 2. All right, and then finally, part C, 9x squared minus 0.64y squared. Now this one's a little different. You'll notice there are x squareds and y squares. And again, I'm not asking you to find an answer, but what I do want you to do is just to factor this thing. So how do we factor this thing? We have to recognize what type of factoring to use, right? With the previous two questions, we could do greatest common factor, then we can factor by inspection. But with this one, what we have to recognize it as is a difference of squares. So 9x squared is a perfect square. 0.64y squared is also a perfect square. So to get the square root of these two numbers, or to get the factor of this expression, we have to find the square root of each term. So the square root of 9x squared is 3x, right? The square root of 9x squared is 3x. And the square root of 0.64y squared is 0.8y. Then once you know those square roots, it's just a matter of using your difference of squares. So 3x plus 0.8y and 3x minus 0.8y. And there you go. So this is something that we've been doing. We do it a lot in foundations. We even started it in NRF 10. So if it's something that you're still struggling with, there's all kinds of practice out there. I would suggest looking at work, doing some practice factoring, because it is a strategy that is probably the quickest and the one that you're going to be expected to remember going forward. So if you do pre-calc 12, it's something that you're going to be expected to know how to do. Okay, so let's take that and let's take it one step further. So here's another polynomial, right? So again, it's just an expression. I'm not asking you to solve for anything. I just want you to try to factor this thing. So here's another polynomial, 12x plus 2 squared plus 24 times x plus 2 plus 9. And the thing here is when you have this pattern that's happening, right? So again, a quadratic looks like this. It looks like ax squared plus bx plus c, right? We have this polynomial, this quadratic that we should be used to. This x is a variable, but this x could be anything. It could be an x, it could be an a, it could be a y, it could be a bracket containing another expression. So notice we have some number, so this would be our a, and then we have something that contains variables. So that's our x's, and it's squared. And then we have another number, which is b. And then we have the exact same bracket. So that'd be like our x. And then finally, we have our 9, which is c. So we still have that ax squared plus bx plus c. So we can still factor it the same way. So again, step 1, we're going to look for any greatest common factors. So 12, 24, and 9 can all be divided by 3. So that would be step 1. 3 onto 4x plus 2 squared plus 8 times x plus 2 plus 3, right? And at this point, what we should do is slide and divide, right? So we're going to take this a value, multiply it onto the end. So we get 3, and then x plus 2 squared plus 8 onto x plus 2 plus 4 times 3, which is 12. Okay, now this thing can be factored. So again, remember this whole bracket is our variable. So we're looking for two numbers that multiply to give me 12, but add to give me 8. And those numbers would be 6 and 2. So we get x plus 2 plus 6, right? That's my first one. And then the x plus 2 plus 2 is my second one, right? And then, so that's our part of our slide and divide. Now we have to do the divide part. Remember, we slid the 4, so now we need to divide by 4. So this goes over 4, and this one goes over 4, right? So then we get the 3 out front times x plus 2 plus this simplified fraction, which is 3 over 2, and x plus 2 plus this simplified fraction, which is 1 over 2, right? And then finally, we need to take their denominators and slide them in front of our variable. So again, the 3 is still there. This 2 slides to the front, so 2x plus 2 plus 3. And this 2 also slides to the front, so 2x plus 2 plus 1. And now it's just a matter of expanding each of these brackets. So the 3 is still there. So this 2 is going to multiply in. So 2 times x is 2x, and 2 times 2 is 4. And then we still have the plus 3 at the end, right? And then same thing here. 2 times x is 2x, and 2 times 2 is 4, and then there's a plus 1 on the end. So now if I combine like terms, I'm left with 2x, and then 4 plus 3 is 7, and 2x and 4 plus 1 is 5. Okay, lots of steps there, lots to process. So like I said, it's worthwhile to practice, right? Find some factoring questions, try them on your own, see if you can do them. Okay, so same thing here, right? Like this one, how would we factor something like this? So again, right, we have to recognize what type of factoring this is. 9 is a perfect square. Since this bracket is being squared, it's also a perfect square, right? 4 is a perfect square. This bracket's getting squared, so it's also a perfect square. So we can use our difference of squares. So if we take the square root of each of these, we get 9 onto 2t plus 1 plus, sorry, that's not 9, that should be a 3 because we're taking the square root, right? So 3, my mistake, onto 2t plus 1 plus 2 onto s minus 2, right? So that's the square root of the first term plus the square root of the second term times the square root of the first term. So again, 3 and 2t plus 1, and minus now the square root of the second term. So 2 onto s minus 2, right? And then we can expand and simplify within these brackets, right? 3 times 2t is 6t. 3 times 1 is 3, right? 2 times s is 2s, and 2 times negative 2 is negative 4. Do the same thing in here. 3 times 2t is 6t. 3 times 1 is 3. Negative 2 times s is negative 2s. And negative 2 times negative 2 is positive 4. And then finally, 6t. There's no more t's, so it's just going to say 6t. There's no more s's, so it's just 2s. But then positive 3 minus 4 is negative 1. And again, 6t, and this time negative 2s, and 3 plus 4 is 7, right? So a little different, probably a little weird, probably not something that you're used to seeing, but still just applying these same skills that we've been practicing. All right, so now that we've had a chance to practice some weird types of factoring, let's apply these skills and find solutions to equations. So again, what we're going to do is we're going to factor to begin. So x squared plus 6x plus 9. The way that we factor this thing is we factor by inspection, right? We're looking for two numbers that add to give me 6, multiply to give me 9. So in this case, it would be x plus 3 times x plus 3. Now this thing should still be equal to 0. So how do you get a multiplication that's equal to 0? One of your terms in your multiplication has to be 0. Now recognize here that both of these brackets are identical. So once I know what x value makes this one 0, the same x value will also make that one 0. So in this case, we're only going to have one answer. All we need to do is figure out when does x plus 3 equal 0. Well, if I subtract 3 from both sides, I get x is equal to negative 3. Okay, let's try another one. So again, same thing here. So again, just like always, I would suggest pausing the video, trying these questions, right? And then once you have an answer, turn the video back on and checking your work against mine. So again, what we're going to want to do here is factor it. So we're looking for two numbers that add to give me 4 and multiply to give me negative 21. So my two numbers here would be x plus 7 and x minus 3. And this thing again is still equal to 0. So now what I need to do is take each of these brackets separately and say, okay, well, when does x plus 7 equal 0? And when does, all right, x minus 3 equals 0? So for this one, we're going to subtract 7 from both sides, and I get x is equal to negative 7. And for this one, we'll add 3 to both sides, and I get x is equal to positive 3. Okay, next question. The number in front of the x squared is not a 1, so this is when we have to start using some of our other strategies like slide and divide or difference of squares or those types of things. I have discussed before in class that we can kind of consider this because this is a prime number and because this is a prime number, we know that the two numbers that are in front of the x's are going to have to be 2's and 1's, and the numbers that are by themselves are going to be 5's and 1's, and then just figure out the combination that's going to make this work. But if you're still not comfortable with that, let's try slide and divide. So we're going to take the 2 and slide it to the end. So I get x squared minus 9x minus 10 is equal to 0. Now I'm going to find two numbers that multiply to give me negative 10, but add to give me negative 9, and they are x minus 10 and x plus 1. Right, now we have to do the divide part of slide and divide. So there's my 2. Okay, and simplify my fractions. So we get x minus 5, right? 10 divided by 2 is 5. And this can't be simplified, so the 2 is going to go in front of the x, and we get 2x plus 1 is equal to 0. So right now, again, what we need to do is take each of these brackets and say, okay, well, when does x minus 5 equal to 0? And when will 2x plus 1 be equal to 0? And again, this one we should be relatively comfortable with. So we're just going to add 5 to both sides, and we get x is equal to 5. Now this one, there's an extra step that we have to do. Again, we're going to subtract the 1 from both sides, and we're going to get 2x has to be equal to 1, sorry, negative 1. Then we have to get the x by itself, so we're going to divide both sides by 2, and we get x is equal to negative 1 half. Okay. So these questions, just like with any other equation style question, right, we can apply them to word problems. And these word problems are actually kind of interesting. This one I'm going to skip over for a second. If you want to try it, go ahead. That's fine, right? All we're doing here is, again, they're asking us to determine when will the dog hit the water. So we're going to have to take this equation, set it equal to 0, then solve. So this would be one of those times where you have 0 equals your equation. And what I would suggest as a first step here is to factor out that 1/10 denominator. So factoring out that 1/10, and it leaves you with negative 3d squared plus 11d. Actually, I'd probably factor out a negative 1/10. So my leading coefficient isn't negative anymore. So I get 3d squared minus 11d minus 20. And then that's something that you can solve for, right? Slide and divide. Okay, if anyone wants to see me do that, just make sure to ask me on our live session day. I wanted to skip it and do a question more like these types of questions because these ones are kind of interesting. So the length of an outdoor lacrosse field is 10 meters less than twice the width. So the length is going to be equal to twice the width minus 10. Right? So the interesting thing about this is we aren't given any numbers. We're not saying that this side length is this long or that side length is that long. But what we do know is that the area of the field is 6,600 meters or 6,600 meters squared. Now, what that means is we know the area of a rectangular field is going to be length times width. Now, the problem with this is we have three variables, right? We have three things that we don't know. Well, we do know the area. We've been told the area is 6,600. So what that means is that 6,600, we'll put it in the place of A, is going to be equal to length times width. But again, we still have two variables. How do we deal with this, right? We can't just say, okay, well, I can solve for one of my variables because there's two things here. But what we can do is use this first piece of information because what this is telling us is, well, yes, length is this length here, but we also know that length is 2w minus 10. So what that means is we can take this 2w minus 10 because we know that that is equal to the length, we can put it into our equation for L. So 6,600 is going to be equal to, and what I'm going to do is I'm going to replace this L with 2W minus 10, and then we'll still have this times W on the end. And what that'll do is now we no longer have A's or L's, all we have are W's, so it's up to us to solve for W. So now what I can do is I can expand this side, so I get my 6,600 is going to be equal to 2W squared minus 10W. And again, just like with previous questions, what you're going to want to do is move everything to one side so this thing is equal to 0. So we get 0 is going to be equal to 2w squared minus 10w minus 6,600. Okay? So the interesting thing about these questions, because they're equations and they're not functions, we don't necessarily have to worry about losing our information. So normally, if I ask you to factor something, you can't get rid of anything. Everything has to still be there. But because I'm not just asking you to factor, because I'm asking you to actually solve an equation, instead of factoring out a 2 from this side, what you can actually do here is you can take both sides of your equation and you can divide it by 2. Because what is 0 divided by 2? Well, it's still just 0, right? And then this 2w squared just becomes w squared, and my 10w becomes 5w, and my 6,600 becomes 3,300. And now I just have a quadratic that I need to try to solve. So at this point, right, finding numbers that multiply to give me 3,300 might be a little tricky. Something like 33 and 100 possibly, right? But they also have to add to give me -5. So there's a couple strategies that you can try to use here. One that I like doing is I like to do opposite operations. And what I mean by that is, for example, I can take this 100 and I can divide it by 2 and I'll get 50. So if I take 33 and I multiply it by 2, I get 66. And what that does is it gives me another set of numbers that will multiply to give me 3,300. And again, I can just kind of work my way through this process. So I could take the 66 and divide it by 6 and get 11. And I could take the 50 and multiply it by 6 and get 300, which is another option, right? I could, let's see, multiply this by 5 and get 55, and divide this by 5 and get 60. Oh, and what I see is that 60 and 55 have a difference of 5. So now if I go back, I get w minus 60 and w plus 55. So what that means, if I set both these brackets equal to 0, so w minus 60 is equal to 0, so w is going to be equal to 60, and w plus 55 is equal to 0, so w is equal to -55. So I get two possible answers here. I get the answer when w, or the width of my field, is 60, and I get an answer when the width is -55. Theoretically, both of these answers satisfy that quadratic equation, but in terms of the context of this question, we don't generally want negative numbers. It's a negative distance, and that doesn't really make sense. And actually, what ends up happening here is it's all about perspective. This 60 is actually measuring in a positive direction, whereas this 55 is measuring in a negative direction. So for anyone here that's taken physics before, when you start applying directions, right, one like positive might be west and negative could be east, right? So that's really all this is saying. But what ends up happening is because math, pure math, considers -55 to be bigger than -60, right? The number isn't really going to make sense in the context of our question. So the answer that we're looking for here is that the width of the field is 60 meters, and I'd imagine what you'd find is that the length of the field ends up being 55 at that point. Yeah, right, because 55 times 60 is how we get that 6600. Okay, so one more question here. Similar idea. What I'd like you guys to do is maybe try to get the answer here. And then if you are unable to get it, um, bring questions with you on Thursday. All right, so there will be a worksheet posted along with these videos. I'm going to try to get a couple more videos in tomorrow, and then hopefully we'll have enough content that you guys should be good to go. All right, I will hopefully see you all on Thursday. Have a